Hi everyone, welcome back to the channel. Today I am taking a behind the scenes look at the app that I demonstrated in my last video. That video covered Markov chains and specifically in a Shiny web app. And Shiny is a tool that's released by Posit and it allows you to create interactives. So I had found an example of an interesting Markov chain problem and I modeled that inside of Shiny so you could have an interactive look at that process. But I wanted to, in this video, talk about Shiny a little bit and then take a look at the code that I had used to write that app. So the first thing I want to show you is this default Shiny app that pops up. If you're in RStudio, which I am now, if you go to a file and then you can do a new file and then Shiny web app, this is the first thing that launches. And there's a little header that says this is a Shiny web application. You can run it by clicking the Run App button above, which is right over here. And then you can learn more about it. The link that is included in the default file is outdated, and it is from the time when Posit was called RStudio. But the link now, the correct link is shiny.posit.co. So you can go visit that if you would like to learn more about Shiny in general. So ignoring the header, we can look at the code below. And the first thing you have is a call to load the library called Shiny. And then the next thing is the user interface. So there's a section of this code, which I will highlight now. This is the user interface section of this code. I'll come back to it in a moment. Below that, you have a section of code for the server. So this would be where the logic takes place for the way that everything is done. And then the last thing is a Shiny app function, which will reference the UI and the server. And it's a very simple line, but it's important because it combines these two and allows the app to run. So if we take a look at the user interface, the first thing we see is a fluid page. And this is a standard layout option. And it allows your panels and everything to sort of move around as they're rendered. And remember that this is rendered into HTML. So if you look at the final HTML, this stuff will make more sense. But the first thing you have is a title panel, and then very easy, you just have some text here in quotes. And the title of this default app will be Old Faithful Geyser Data. Then there is a definition for the sidebar layout, meaning to the left there will be some interactive options for you as a user. And that layout contains a sidebar panel, which itself contains a sidebar input, which is the actual tool that you will use to interact with the data. And this one has a few arguments here. We see bins, number of bins, and then a min, max, and value. So the min and the max are the minimum and maximum of this particular input. The number of bins is the text that you see on it. The value is the preset value that you can choose. And then bins references the variable that we see in the server later. And so that's really important. So that's what connects these two things. And then the other part of the interface is the main panel. And this is where you will have your rendered output. This is the result of your interaction, if you will. And so in the main panel, we have plot output, and that references another variable called dist plot. And so we'll see that as well. Now, if we jump down to the server, you'll see it's a function that takes an input and an output. And then you'll see this output $dist plot. So this is one of the outputs. It's actually the only output in this case, and it is named dist plot, which is what is linked up here in the plot output. And this is specifically created using this render plot command. And you'll see a parentheses and then a curly bracket, and everything in between there is the logic to create your histogram that will be rendered in the app. And we'll see that in a moment. So this uses the geyser data set, and it looks at the wait time between eruptions. So I'm not going to get into the details of how they do this, but they draw a histogram to show the frequency of each of those values. Now, bear in mind we have the plot generated here in the server function, and it's linked so that it shows up in the plot output. And then the bins variable that is established in the server is controlled by the slider input in the UI. And then, like I said before, everything is rendered here with this Shiny app function. So what we can do, just leave it alone as is. This is the default. I haven't changed a thing on here other than the link to the more information about Shiny. So when we run this, we have to save it, and then it'll pop up. So this is what it looks like. We see a slider with the title number of bins. We see the title bar like we talked about. And then we see the output on the right in the main panel. And the idea is that as a user, you can come in here and change the values. So with one bin, obviously the histogram is not really useful. If you go to 2, you see the 2 bars. At 4, it looks like maybe it's a skewed distribution here. As you start to increase that, it looks more like a bimodal distribution. And then as we really crank that up to the max, we can see the most segmentation here, and it does in fact look kind of like a bimodal distribution with some higher peaks on the right side. So that's essentially how the Shiny app works. If you have an account with Shiny, you can publish this to that site. So there's an option to publish up here. I'm not going to cover that today, but that's essentially how it works. And as you can imagine, there are many ways that this type of technology could be used. I'm interested in this from an educational perspective, but it can be used for a lot of different situations where you're developing dashboards and you want the users to interact with the data on their own.